I'm pursuing glaciology at Stockholm University. Glaciers are found in the high alpine regions around the globe, and they are often used to describe global warming because they're so expressive. We'll say a few words about why they are so expressive. If you look at the small glacier in like this, in a little circle in this case in northern Scandinavia, in the wintertime you get snow that is the whole glacier, and it's a little bit less in the lower parts and compared to the upper parts, because in the upper parts you have often a head wall which works as a trap for blowing snow, which means that you have higher of snow in the upper parts than in the lower parts. And then in the summer, ablation processes, the most powerful one is melting, and we have a lapse rate with altitude, which means that it melts more on low altitudes than in the upper ones. And that means that in the lower part of the glacier, all snow will vanish, and then will be removed as well. But in the upper parts, you have more snow from the very beginning, and then you have less melting, which means that you will gain mass in that region. If we in a more in map form, this is from in northern Sweden. It's a randomly chosen year, and if you express these processes, you can see here that in parts which is indicated by red, are in meters. You can see here during this year the glacier lost more than 2 meters in the lower parts, gained 2 or 3 meters in the upper parts. If the system is in balance with climate, then the loss should equal the gain. And you can see that in the middle, this is what we call the equilibrium line. Then if the system is in balance, the flows of ice through that line should also equal both the gain and the loss. Also expressed in a more figure like this, where you can see that the glacier front is in the lower part, and you had a head wall in the high up. And you can see that in maritime climate you have much bigger change with altitude compared to a continental area. The reason for that is that in the continental area it's not only melting which is the governing processes, it's also evaporation. So this is the reason why you get kind of glaciers are also moving. In an alpine area you have 2 different process for movement. One basal sliding, and to slide, the glacier must be at a pressure melting point at the base, so it melts. And process deformation, so it's kind of a flow. Both these 2 components gives the total ice flow. We often divide or classify glaciers in some different ways. The most commonly used is the morphological one, where we talk about glaciers and subglaciers, which describes what they look like and how they are situated in nature. And then we have plateau glaciers, and then the bigger ones, ice caps and ice sheets. We have just 2 ice sheets in the modern world, and that is in Antarctica and on Greenland. The size difference between these 2. And then one which is a little bit more physically based, and it refers to the temperature distribution within the ice. And most important difference here is that we talk about temp glaciers and and polar glaciers. Temp glacier is at the melting point all through, and it melts all year round. And again, the ice is at the melting point. It's both in subglacial drainage systems, and it hides over the substratum. The other one is polar glaciers, and they are at below freezing point temperature. So they can be, if they are very thick, as for example Antarctica, then it will reach the pressure melting point at the bed. But normally they are frozen to the bed, and the polar glaciers are subdivided in two different groups. One high polar glacier, which is what we find, for example, in Antarctica, where the transition between snow and ice is completely dry. There is no water or meltwater involved in this. There is no runoff, surface runoff, and there is no englacial drainage. There may be some subglacial drainage if the glacier is as so thick that it reached the melting point in the bed. The other version of polar glaciers are the subpolar glaciers. They're frozen to the bed. The surface runoff during the ablation season, and they have a rather primitive sub and englacial drainage. Then, as most glaciers are something in between these the areas, we also have another word which is actually the most commonly one, which are called polythermal. Means that they have ingredients of both temp glaciers and subpolar glaciers. Glacier in a mountain area is different rules. One is that it works as a magazine, and that means that it evens out changes in flow rates, in flux rates in the rivers. But there's also another aspect, and that is can be seen on this picture, where this is in the subarctic, where you often have ice cored moraines in front of the glacier, and you can see that there is a lake in between these moraines. And if the climate gets warmer, these moraines may melt down, and suddenly such a lake can be drained, which can be very catastrophic in mountain areas. This is a common problem in, for example, Himalayas and the Andes. If to more to the polar regions, you have other things that you can study on glaciers. You can see this is from East Antarctica, where the inland ice has reached the sea, and you can see here annual layers. In this case, there is melting on the surface, so everything is preserved. So the content of this snow does really mirror the content of the atmosphere. Why ice cores are taken from, for example, from Antarctica and also from Greenland. These are all as a geological process. This is what we can see in most mountain areas where we have had glaciers in the past. This is a U-shaped valley, or U-valley, which is indicative for had glaciers, and this is from the Ice Age, of course. So, to why do we study glaciers? They are excellent climate indicators, and they are influencing the sea level. They regulate water flow in rivers. Rain in lakes can cause catastrophic floodings, and this is a reason for keeping track on them. And then glaciers are climate archives. And then glaciers can be studied as an efficient erosion process, and this has importance for how we believe that the landscape will be modulated during